So yesterday we touched on what an imaginary number is and briefly mentioned what a complex number is. So today we're going to do more with complex numbers. What exactly is a complex number? It's the highest number known to man to date. It is part real, part imaginary. What makes it complex. So in the realm of complex numbers, basically this is how math evolved. First, there were just natural numbers, the numbers 1, 2, 3. Believe it or not, there was no need for the number 0. Why do you need a number to represent nothing? Well, after a while, we did have 0 represent nothing, so we went from natural numbers or counting numbers to whole numbers. And then after whole positives, somebody said, well, why can't we go the other way, representing negatives? And then somebody said, well, what about the numbers in between the numbers we know, which were rational numbers? And then we kind of got separated because these were all sets to each other. A natural number is a whole number, and a whole number is an integer, and an integer is a rational number. And then we got to the irrationals. They are different than rationals. Rationals are fractions, defined as an integer over an integer where the denominator can't be 0. So here came irrationals, those numbers that can't be expressed as fractions. And then sitting outside of them all are the imaginaries. They are not connected to the world of reals anyway, but they can be put together to make the universe known as complex numbers. That's a little set notation there, theory for you. All right, so let's boil it down. What are we doing with these lovely complex numbers? Well, everything we've ever done to any numbers. We have to be able to add them, subtract them, multiply, and divide them. Well, adding complex numbers and subtracting complex numbers are really simple. It's kind of like algebra, where you can only add x's with x's and y's with y's. So when I look at this, basically I'm going to take the real parts, which are 3, 6, and add them together to get a new real part. And then the imaginary part of negative 4i, I want to add that to the other imaginary part of negative 2i. So I have just created a new complex number. It would be the complex number 9 minus 6i. So I think you can get how subtraction works. Same thing. We're going to take the real parts, which are 3 and 6, but this time we're going to subtract them. Then we're going to take the imaginary parts of negative 4 and negative 2i. This is negative 4i. So I have negative 4i subtract negative 2i. And that's the only way you can screw subtraction up, is to forget about the double negative. Subtracting a negative. So when I clean that all up, 3 minus 6 means my real part is now negative 3. Negative 4 minus a minus 2 means that my imaginary part is minus 2i. Multiplying complex numbers. Remember, we tell you that when a mathematician invents another set of math, it has to apply to all the other math rules, so it has to be able to be multiplied. And multiplying complex numbers is just like multiplying binomials, because complex numbers are binomials. So whether you want to distribute or whether or not you want to set up the good old box, choose your weapon of how to multiply. Well, I still like distributing. If you like the box, go for it. But 3 times 6 is 18. Well, that's a real number. 3 times negative 2i, that's an imaginary number. Negative 4i times 6 is negative 24i. But careful what happens here. Negative 4i times negative 2i is positive 8i squared. Because remember, a complex number can have only two parts, a real part and an imaginary part. So I clearly see my real part of 18. I can see my imaginaries. So where does 8i squared go? That's right, you got to remember that I squared is really a negative 1. So this really is 18 minus 6i minus 24i minus 8, because I squared is negative 1. Negative 1 times 8 is negative 8. Now I can put together my real parts, which are 18 and minus 8, to give me 10 real parts. And then I can put together my imaginary parts. And I have negative 30 imaginary parts. No, that doesn't look like a 3, but it is. Dividing a complex number is a little more complicated, but not really. Because if you remember, we learned that I is really the principal square root of negative 1. And now, hopefully your brain remembers that you can't have radicals in denominators. So earlier in the year, we may have given you one that looks like this. And we had to use a conjugate to do that division from earlier in the year. Once again, same thing, because this is really a denominator that contains a radical. So the conjugate is the key word that you have to remember when dividing complex numbers, because it is really a radical. So the conjugate of 6 minus 2 square root of negative 1 is 6 plus 2 square root of negative 1. But we're not going to write square root of negative 1. We're writing I instead. So now I'm going to multiply the top by its conjugate. And I said it's a little more work because now you have to double distribute, multiply, FOIL, use your favorite word twice. So let's do the bottom. 6 times 6 is 36. That would be plus 12i. And now we know that this is just like multiplying a difference of two perfect squares before we got there. Negative 2i times positive 6 is negative 12i. And then negative 2i times positive 2i is negative 4i squared. Can you see why we do the conjugate again here also? That's right, the middles are still going to cancel out. The negative 12i and the positive 12i will cancel out. We just saw in the other problem that I squared was a negative 1. So this is 36 minus a minus 1, which means this bottom turned into 37. And that's what we want in a denominator. We can't have radicals. All the radicals are gone. All right, so if I clean this up here, the last thing we have to do is multiply out the top. And hopefully you guys are pretty adept at multiplying a binomial by a binomial. You should be able to fly here. That's 18 plus 6i minus 24i minus 8i squared. It almost is the same as our problem over here in multiplying, but because this was a 6 plus 2i and this one was a 6 minus 2i, little sign change. So now, first thing I'm going to say is this is negative 1 times a negative 8 really gives me a positive 8. So adding our real parts together, 18 and 8, we have 26 real parts. Combining our imaginary parts together, 6 minus 24 tells me my imaginary part is negative 18i. Now, if I could reduce, if there was a number that goes into 26, 18, and 37, I would continue to reduce, but there is none.